This video is about quadratic factoring.
So the first type of factoring we want to learn is factoring out the greatest common monomial factor. The word monomial just means one term. So you're looking for one term that you can undistribute from all of the terms that are in the expression. So in the first example, we have 4x minus 10. The greatest thing that we can factor out from both of these terms is the number 2. So you'll factor out the 2 and show it in front of the parentheses, which is where it would be before it got distributed, and then divide each of the terms by 2, because the opposite of distributing is dividing. So we want 4x divided by 2 is going to give us 2x, and minus 10 divided by 2 will give us minus 5. And that's the factored version of 4x minus 10. To factor something means to write it as a product of factors. So we wrote the same expression as a product, and now it's considered factored. So in the next example, we can take out a 3x. That's the greatest term we can take out from all three. Divide each term by 3x, and you'll be left with 2x squared minus 6x and plus 3, and then stop. So you've written it as a product of 3x multiplied by this trinomial factor. Trinomial means 3 terms. And then in the final example, just to show that it still applies if there are multiple variables in there, the greatest number you can take out will be a 12, and when the first term is negative, you're expected to take the negative out as well. But we can also take out 1x, and we can take out y to the third power, so 3 y's can come out, because the first term has y to the third in it, and the second term has y to the fourth in it, so the most you could take out would be y to the third. Divide each term by negative 12xy cubed, and all you'll be left with in the first term is one single x, and what you'll have left in the second term is minus 4, because positive 48, when you divide it by negative 12, is minus 4, and a single y will be left over there. So this is written as a product. Another type of factoring is when you have a quadratic trinomial. This is a 3-term expression. It's quadratic because of the x squared. So to define each of those words, quadratic because it has x squared in it, 3 terms, makes it a trinomial. There is no greatest common factor we can take out of this first example, but hopefully you recognize that when you see x squared minus 9x plus 20, that's the result of a FOIL problem, or a binomial expansion problem. So when you multiply a binomial times another binomial, you get something like this, trinomial. So we want to unfoil this. We want to rewrite this as a product of 2 factors. So we're going to set up these 2 parentheses, which would have been the 2 factors that led to this result. And we know that the first thing you do in binomial expansion is multiply the first term in each parentheses together. So x in the first parentheses and x in the second parentheses would give us x squared. Then we want to look for factors that multiply to make 20 and add to make negative 9, because the last 2 digits or the last 2 numbers in these parentheses have to be factors of positive 20, and then when you add the middle terms together to combine like terms to get negative 9x, they have to add up to that coefficient negative 9. So we're basically thinking of all the things that make 20, which would be 2 and 10, or negative 2 and negative 10, 5 and 4, or negative 5 and negative 4, and so on. And I just list them in my head until I figure out the pair that's going to add up to the middle term that I'm looking for. And I reach negative 5, negative 4, and stop. Now if you want to check, you can always FOIL or expand that. You could do it mentally, you could write it down, and sure enough you'll see that when you multiply these 2 things together, you'll get x squared minus 9x plus 20. Sometimes, no matter how long you think about it, you won't be able to find a pair. So if we look at the factors of negative 12, they're going to be 2 and negative 6, or negative 2 and positive 6, 3 and negative 4, or negative 3 and positive 4, 1 and negative 12, or negative 1 and positive 12, and there aren't any others. And none of those pairs adds up to that middle term that they would need to add up to. So when this happens, and you are 100% certain that there are no factors, then you can say that it is prime. Prime because the only thing that you could factor out would be a 1, just like prime numbers. And then in this final example, we're going to put the 2 things together. We can factor out a 2, the way we practiced on the first slide. And then the thing left inside is a quadratic trinomial. So we want to keep the 2 shown, but break up this trinomial into 2 binomials. And we're looking for factors that multiply to make 8 and add up to positive 9. So our factors that make 8 would be like 2 and 4, or 8 and 1, and 8 and 1 is the magic pair. We fill them in, and we stop. There are a few special versions of quadratic trinomials. They're still quadratic trinomials, but what's special about them is that when you factor, and you're looking for that pair that multiplies to make 25 and adds up to -10, if you end up with the same number twice, then it's considered a perfect square. So what multiplies to make positive 25? Our options are 5 and 5, or -5 and -5, and I can stop there because I can see that's my pair that will add up to -10. This is the same exact binomial twice, and so you can rewrite this as x minus 5 quantity squared. It's better written like that, and it's considered a perfect square trinomial because it's the same exact binomial to the second power, and that's what squared means. So hopefully you figured out with this next example. Positive 9 breaks into 3 and 3 because that also adds up to 6, so we can write that as x plus 3 to the second power. Slightly different is a difference of squares. So there's still the word squares in there because this time the two numbers that you're looking at in the original expression are perfect squares. And there's a subtraction sign in between them, which is what the word difference means. So when you're subtracting two numbers that are perfect squares, it's a special factoring pattern. It doesn't look like a trinomial, but you can almost think about it as this trinomial. The middle term is invisible because it has a 0 coefficient. So it's like the factors you're looking for have to multiply to make -49 and add up to 0. This is the case only when it's subtraction because you think about the two numbers in the middle basically canceling each other out. And so you need a positive times a negative so that the two middle terms will cancel. So when you factor x squared minus 49, you're going to use plus and minus, and it's whatever the square root of that 49 is, which of course is 7. And this, there is no other way to write it because each of the parentheses is different. Each binomial is different. But that's the only way to factor x squared minus 49 because the middle two terms are supposed to cancel out. So you have to get the same number twice but with different signs. And the second one is an extension of that. There's a number in front of the x squared that you can't factor out. So there's nothing you can undistribute here. And so we just need to imagine taking this 4x squared and splitting it into 2x and 2x. Which is not something we've done before, but it should make sense. It's the square root of 4x squared, so 2x times 2x. And then the minus 81 is going to become a plus and a minus 9. And so this is another difference of squares. And just note that it's not going to work if you have a plus sign. So if you were to have an expression like this, the sum of squares, you would have to say that it is prime. Because the sum of squares won't work. Often students try to do this. They think, oh, well, can't I just make it positive 5 and positive 5? But if you were to actually FOIL that out and think about it, you'd see that you'll have that plus 5x and another plus 5x in the middle, which won't cancel each other out. And so you have a middle term, which the original expression didn't have. So you cannot factor the sum of two squares, only the difference of squares. And that is all.